Okay, we're going to start with example 8 today. So this will be kind of a quick review over what we worked on last week. So we're going to graph this equation, but before we graph it, I want to talk about a couple of things. Now, this equation is not multiplied out. It's in factored form. Okay, but if you look at this exponent here of 2, so this would be an x minus 1 times an x minus 1, and you multiply that together, that's going to be squared. You're going to end up with an x squared. But you are also multiplying times this other factor of x plus 2. So this x times that x squared would give us an x cubed factor. So this is going to be a cubic, okay, which means it falls into the odd category of our polynomials. You're either going to be odd or even. So since the degree is 3, it's going to be an odd. Then the other thing is right here. This a is a -1. So it's going to be an odd, but it's going to be a negative odd. So the shape of this is going to look something like that. Okay, the other thing I want you to notice is since this is in factored form, that's going to tell us more about the graph. So this first factor, x plus 2, if you put that equal to 0 and solve, you get x equals -2. Then this factor, x minus 1 equals 0, and x equals 1. So you have these two zeros or solutions, or remember, that's the same thing as x-intercepts. So not only do we know the shape of this graph, but you also know that it's going to go through the point at -2 and also the x-axis at +1. Okay, so we already kind of know the shape and we know some of the points that it's going to pass through. So on your calculator, you'll notice that you can enter this in factored form. Your parentheses are above your 7 or 8 and 9. And then I can use my squared button over here at the end for the x minus 1 squared. So that squared button will put that exponent of 2. All right, if we graph this, there's our shape. So again, it's a cubic and it's negative. So it starts high and it ends low. And then if we hit trace, you will see if we go to -2, there's that point, -2, 0 that we already had. And then also 1, 0, there's another x-intercept, and we already had predicted that because this equation was in factored form. So I'm just going to use a couple other points to sort of orient my graph. So I've got the point 0, -2. So plot that point. And then if you look to the left, we kind of have a low spot. So if I go down there, I'm guessing it's at about a -1, -4. So I'm going to go ahead and put in -1 in my calculator, enter, and I was right. It's at a -1, -4. Now, really, that's about all you need. You might want to go over here to maybe a +2 and see that you get a -4. That point would be helpful. But again, you know the shape is going to come down. It's going to turn there at that low point. It's going to come up and get this x-intercept at 1, and then it's going to turn and it's going to go back down. Okay, so there's my curve, and I just used about four or 5 points to set that curve up. Okay, so that is kind of a review over what we did last week. Now we're going to move on to example 9. Okay, let's take a look at, actually let's look at B first. I'm going to blow this up so you can maybe see it a little bit better. All right, we are estimating the coordinates for each turning point and state whether it is a local minimum or maximum. Estimate all zeros and determine the least degree that the function can have. Okay, so what is it we're looking for? We are looking for local mins and maxes. We're going to find the zeros, and we're going to talk about the degree. All right, so if you look at B, you'll notice it's this W shape. So that's going to be an even polynomial. So it'll be like a 2, a 4, a 6. Okay, but this is what you can do. You can look at these turns. So if you act like you're driving a road here, and I have a turn here, and a turn here, and then I have another turn here. So the least degree is going to be your number of turns plus 1. Okay, so I had 3 turns here, add 1, and I get a 4th degree. So this graph has to be at least a 4th degree. Could be 6, could be 8, but it has to be at least a 4. Okay, if we back up to A and look at the turning points here. So I'm driving along, I've got a turn here, turn here, turn, turn. So I've got 1, 2, 3, I've got 4 turns. So the degree on this one is going to be 4 turns plus 1, and that's a 5. And that makes sense because if you look at the shape of the graph, I'm going, this is negative infinity on this side, positive infinity on this side. So you've got part of it going either direction. Okay, on B, we have it opening up. So both parts of the end behavior is going to positive infinity. That's what evens do. But odds, one negative infinity, the other positive infinity. Okay, so then let's look at, while we're talking about these, let's talk about the zeros. Okay, your zeros is another word for x-intercept. So when we're looking for zeros, we're looking for where it crosses the x-axis. Okay, so zeros. On B, looks like we have a 0 right there, 1 here, and 1 here. So I have 3 places where this graph crosses the x-axis. You're just going to estimate. So I'm going to say that first 0 is at about -1. Then the second 0, maybe that's about a 0.8. And this third one, I'm going to call it a 2.5. Okay, if we look at A over here on the left, we have 0 here and here, and another one here. So this one also has 3 places where it crosses the x-axis. So that first one, maybe that's a -1.8, and then a -1, and then maybe a +2. Okay, so that takes care of our degree, takes care of our zero. So now we need to talk about minimums and maximums. So now let's go back to B again. So you can tell that this point here is a minimum. It is the lowest point on the graph. Okay, that's called a true minimum. There is no other point that's lower than that point. So let's estimate what an ordered pair for that might be. Looks like maybe about a 1.8 and a -6.2. Okay, we'll call that our minimum. Okay, now there's also a minimum value right here. Now, it's not the true minimum because these other points on this other portion of the graph is lower than this one. But this one is called a relative minimum, or we could call it a local minimum. Okay, so it looks like it is at about -1, Okay, so what a local minimum or a relative minimum means, in its little section of the graph, it is the lowest value. Okay, and it does. I mean, it certainly is the lowest point on that section. Okay, we have one other point that we're interested in. That's the point right here. So this is a high point. This is going to be a maximum value. And at 0, 2 is the max. Now, again, this isn't a true maximum value because both sides of this graph go to positive infinity. So it's not going to stop. But for its section of the graph, it's a maximum value. Okay, looking at this other one, we have some local minimums and maximums. We have this point here that I would say is a local maximum. So about a negative 1.5 and a 2.5. Okay, you're just estimating. And then right here next to each other, let me make that a little bigger yet. Okay, you have a low place, so you have a minimum, and you also have a maximum. Okay, those are still local mins and local maxes. So let's do this one right there. So minimum, maybe it's about a negative 0.2 and a negative 2.2. Okay. All right, so that's this point as a minimum, about right there. Okay, then we have this little guy, and it's a maximum. So that's going to be at about maybe a 0.3 and a negative 1.8. And then we have one more, and this would be another local minimum. So minimum at about a 0.75, the negative 6 maybe 3. Okay. All right, and there's the extrema values. One more I'd like to look at today, and that's this letter D. We won't go through everything because I'm pretty sure you guys are getting the hang of this. But I do want to look at the local minimums and maximums. So if you look at this, you'll notice that there's 1, 2, 3 turns. So when we talk about degree, we said number of turns plus 1, and I get 4. Okay, however, I don't think that all of these turns have a local maximum or local minimum value with them. Okay, now there's definitely a minimum right here. Okay, but, well, let's go ahead and name that. That's about a negative 1.2 and a negative 4.1. Okay, but I don't think these other 2 points here and here would qualify as a maximum or a minimum. Okay, so they are on the curve, but if you look to either side, like one side's below, but then the other side, it's above. So I don't think that really classifies as a maximum or a minimum. So I would say this graph just has one minimum value, and that's all. Okay, so that's it for today's lesson.